In this video, we're going to examine the LCDE implementation for MSP430FR4133 Launchpad. So we're going to use the examples provided on the Resource Explorer, which we can find in the Code Composer Studio. So to check on the examples, so we can just go on the software and then proceed with the MSP430 where, and then proceed on the libraries. On these libraries, we can see different type of library, but what we exactly need is on the driver library, which we can find the different launch pads. Since we're going to use the MSP4304133, that is a frame, so we can check in this part, and then we can have the examples here. So on the examples provided, we can check the different types of peripherals which we can associate with 4133 Launchpad. Then we can check on the peripheral of LCDE. So we can just click on this one to check on the example provided available. So we can have here the LCD, we can just double check or double click, and then we can have here the LCDE example 1 for Max. And then the next thing we're going to do here is to import this one to IDE. Since we have already imported this one, so we can just skip on this part. So once we import the file, so we can check already on the Project Explorer, which we have here on this part, the LCDE example 1. So we can just check on here the different components, which include the driver library, and then the target configurations, and your linker command file. Since we're using the MSP430FR4133, the linker command here is already predefined to our specific launchpad. And then you have here the C file, which is equivalent to your main file. So we can just double click this one. So once we double click the C file, so we can have here the component. So if we try to take a look on the figure, so I tried to zoom in the window so we can have clearer view of the codes provided on the C file. This C file is equivalent to your main C file, which if we try to examine, this includes the main void. But what exactly we're doing here, if we go over on the examples description, it says LCDE use the 4 Max example, because for FR4133 it can use up to 8 Max, meaning the pins we're going to use and the segments and the communications are maxed together to limit the number of pins. Because ideally for MSP430, the very purpose why we have to do the maxing is to minimize the use of pins, because the number of pins usually represents the cost, because the greater the number of pins, meaning the launchpad will have a higher cost. So what do you mean by 4 max? For 4 maxings, usually we use the 4 LCD segments and 4 common lines. What are those common lines? Which is communication 0, which we have here, 1, 2, and 3, which represents the line 1 or line 0 up to line 3. Given the number of 4 LCD segments and 4 communication lines that being used for 4 max, there are a total of 8 pins. So we just limit the number of 8 pins, allowing us to maximize the use of the LCD screen. So basically, we have here the built-in code that we can see here. Typically for MSP430, we have the watchdog timer, and then we have the GPIO setting, which we allow the external input, crystal, which will be used as our peripheral mode function input. And then we have here the external clock source, which is 32,768 Hertz. Usually this one is equivalent to our clock source, which is our auxiliary clock, because for auxiliary clock we have a built-in or predefined frequency of 32 kilohertz. And then we have also here the flag timeout. And then for the power module management, we use the PLLPM5 on this part. And then in order for us to implement the LCD, so we need to identify the functions as to different segments. So we have here the LCD set pin as LCD function, which we allow LCD 0 to LCD 26 to be our active segments, and the LCD 36 to 39 will be our communication line. That communication line acts like a grounding, connecting all the numbers or 27 segments that we can use. And the next thing we're going to do here, we have to set the clock divider. So usually we have here the clock divider 8. But if you want to change this one clock divider, so you can just do it by taking the right click and then open declaration. So you can see here the different list of clock divider which you can use. Ideally, the clock divider represents how many times you divide. So basically, for example, if we're going to use the 32 kilohertz clock source, and if it's divided by clock divider 8, so you have to divide 32,000 divided by 8. So going back to our LCD.C, what other else parameters that we need to define? Basically, we have the formax, since we're using the formaxing here, so LCDE formax. And then we have to enable the LCDE segments. And then after which we'll be using the LCD initialize. Here we have to initialize the LCD right away on the C file, because we don't have the main C file. We use directly the LCD C file as our main file. But typically, if you want to initialize them using a main C file or main.c file, so we can do it on a separate C file. And then we have here the different voltage source, and then enable the charge pump. And basically, after we have all of these things, so we have to clear the memory. That's basically a practice for LCD implementations. We have to clear the memory. And then after which we have to configure, which we need to assign the communications, the grounding. So we will be calling the function LCD set pin as communication, which we allow the line segments 0, 1, 2, and 3 to be our communication 0, 1, 2, and 3. Meaning these line segments represents the grounding or the communication lines for the segments. And then after that, we have to set the memory on the different parameters. Basically, for this example, we'll be using the 1, 2, 3, 4, 5 string to check or to appear on the LCD of the launch pad. So how do we set this one? So you have to set the memory using this configuration, which you have the LCDE set memory, including these three components: the LCDE base, which we have always because we are using the LCDE type of launchpad. And then we have to set the memory blinking, which we can have 2, 4, 6 up to 18. So it's up to you if you want to change the LCDE blinking memory. It will not change actually, but if you set typically for the display, there should not be two strings that have to be stored on the same memory. That is why if we try to take a look on the display, we can check here the 1, 2, 3, 4, 5, 6, which is equivalent to the different blinking memory. So how about this last part here? This is a hexadecimal value of the different strings. So going back to our previous examples before, so if we try to take a look on this one string, so if basically we have to write them according to their address segment. So what are those equivalents? So we have here the different constant characters, which represents the numbers 0, 1 to 9, and then the characters A to Z. So if we try to take a look on this 0x60, which is equivalent to your 1, it means it has to display 1. And then next, for 2, that is DB, it is the same thing, F3, and then so on and so forth if you want to change. Then after which we have here the turn on LCD. So after we set the memories on the different blinking memories provided on the segments, we can now set the LCD to on, meaning it will appear right away on the screen. And then after that, we'll be using the LPM or the power management module to turn off the process. So the next thing we're going to do here is to build to check for any errors, and then after which we have to debug. In debugging, usually we have to make it sure that the launchpad, the exact launchpad, should be plugged into our computer to avoid problems that occur. So we have here, we successfully debug, and then when we run, so we can definitely appear on the screen the 1, 2, 3, 4, 5, 6. But ideally, so we cannot see it right now, so we have to click the run button and it should be appeared on the screen. So if we want more individually to appear on the screens as one by one, so we can have it by run over or step over and introduce a breakpoint. So basically it's just a very basic. So basically it's just the fundamentals on how we appear the data on the LCD screen. But if you want more, like if you want it to be blinking, so we can introduce some different types of commands or functions into the screen. So if, for example, if I want it, then so if I want to make this one blinking, so I just have to stop, and then we just have to use or enable the blinking control. So how are we going to enable the blinking control? So basically we can just copy it to other C files which have the same, so we don't need to write anymore. So this is how we segments or the display on the segments, and that's, we'll be using the call function LCDE set blinking control, which is composed of the LCDE base, LCDE blinking frequency, which is press scalar to 64, and then the LCDE blink mode individual segments. So let's try to debug again. So once we after debugging, so we can just click resume here or run. For this one, because we have the breakpoints, so we can just click again and we can see it. It should be seen on the screen of your MSP430FR4133 that the string 1, 2, 3, 4, 5, and 6 are blinking. And some more, if you want to add some specific functions into the LCD, we can have, just to close this one first, and then I'll show you. So I'll show you this one. So these are the different codes that we can set for the LCD to appear differently, like blinking, so we have to set for the heart, the timer, and then what else? And then alternating blinking on this part. So we can just copy them and then paste right away onto our lcd.c file. So that's how simple the implementation for LCD